Hello everyone. In today's lecture we will discuss the topic AC through pure resistance. For this, let us consider a circuit consisting of pure resistance having a resistance of capital R, and this pure resistance is connected with a source of AC supply. And let us suppose that the equation of the alternating EMF is represented by small v is equal to capital Vm into sine omega t, where Vm is the maximum value of the alternating EMF or the alternating voltage. So we are giving this voltage supply to a circuit which consists of a pure resistance whose resistance value is capital R. So when we give the voltage small v to this resistance R, then a current will flow in the circuit which will be also of alternating nature. So as a result of this alternating voltage, an alternating current will flow in the circuit. Let us assume that the alternating current is represented by small I. So if small I be the current in the circuit at time t, then from the voltage and current relationship according to Ohm's law, we can write small v is equal to small I into small r, that is instantaneous voltage is equal to instantaneous current into resistance. So the value of current will be voltage upon resistance, and we know that we have assumed that this instantaneous voltage is given by Vm into sine omega t. So we will substitute the value of Vm in this equation. So this equation comes out to be small I is equal to Vm sine omega t by capital R. In this equation, Vm by R is a constant quantity. So we have written this is equal to Vm by R into sine omega t. Vm by R is a constant quantity. This is voltage upon resistance, and we know that voltage upon resistance is nothing but it is current. And since this is the maximum value of voltage, so the current corresponding to this value of voltage will also be maximum. So let us represent the current in this case by Im. So Vm by R is equal to Im. If we substitute this value in this equation, then we get small I is equal to Im into sine omega t. Let us suppose that this is equation number 2. So in this equation number 2, we find that Im, what is Im? Im is Vm by R, and actually what is Im? Im is the maximum value of the current, or it is also known as the current amplitude, that is the amplitude of the alternating current. Im is nothing but it is the amplitude of the alternating current. So we can say that Im is the maximum value of the current, or we can also call it as the current amplitude. Now if we compare the equations 1, this is the equation 1, V is equal to Vm sine omega t, and the equation 2, I is equal to Im sine omega t, we find that both the equations have the term sine omega t. So we find that both the alternating EMF and the alternating current are in phase with each other. At time t is equal to 0, the value of the alternating voltage and the alternating current both will be equal to 0. Similarly, at time capital T by 4 or omega t is equal to pi by 2, that is at omega t is equal to 90 degree, the value of current will be maximum and the value of voltage will also be maximum. Similarly, at time capital T by 2, both the voltage and the current will have 0 value, and so on. So if we plot both the instantaneous voltage and the instantaneous current with respect to time or omega t, then the plot will come out to be as shown in this figure. We have plotted both the instantaneous value of the voltage and the current along the y-axis, and we have plotted the time or omega t along the x-axis, and we get a graph. This is the graph of the alternating EMF or the alternating voltage. So it has been represented as V is equal to Vm sin omega t. And similarly, this is the graph of the graph shown by dotted line is the graph of the alternating current. So from this graph we find that at t is equal to 0, both the alternating current and the alternating EMF both are 0. At t is equal to capital T by 4 or omega t is equal to 90 degrees, we find that both the voltage and the current will have maximum value. Similarly, at capital T by 2 or at omega t is equal to 180 degree, both voltage and current will be 0. Similarly, at omega t is equal to 270 degrees, both V and I will have negative maximum value, and at 360 degree both value will be 0. So we find that from this graph that both the voltage and the current attain their 0 and maximum values together. So there is no phase difference between the alternating EMF and the alternating current in case of purely resistive circuit. So we can say that in case of pure resistor, both the alternating EMF and the alternating current are in phase, or we can say that the phase difference between the alternating current and the alternating voltage in case of pure resistor is 0 degree. That is, there is no phase difference between the alternating EMF and the alternating current in case of pure resistor. Now we will calculate the value of power in purely resistive circuit. We know that the power at any instant is the product of instantaneous voltage and the instantaneous current. That is, power at any instant will be equal to small v into small I, and we know that small v is Vm into sin omega t, and the value of I has come out to be Im into sin omega t. So this can be written as Vm into Im into sin square omega t. So the average or the true power over one cycle of the alternating current will be equal to the integration of this power within the limits 0 to t, because we are calculating the true power over one complete cycle, and one cycle is equal to one time period, that is equal to capital T divided by the total time. So we have integrated dt over the limit 0 to capital T, which is one cycle. So this comes out to be Vm into Im by t integration of sin square omega t dt from 0 to t. Now if we solve this, that is if we integrate sin square omega t dt within the limit 0 to t, then this value comes out to be capital T by 2. On solving, this value will come out to be capital T by 2. So the average or true power over one cycle of the alternating current will be equal to Vm Im by t into capital T by 2. This is equal to Vm Im by 2, and Vm Im can be written as Vm by root 2 into Im by root 2. This is equal to Vrms into Irms. That is, the average or true power over one cycle of alternating current is equal to Vrms into Irms. So the average power or true power over one cycle of the alternating current is the product of the RMS value of the alternating EMF and the RMS value of the alternating current. Now if we draw the graph of power and time, then we find from this graph that the power is consumed at all times except when both V and I are 0. That is, no power is consumed here, no power is consumed at 180 degree, no power is consumed at 360 degree, and so on. That is, there is no consumption of power only when both V and I are 0. Otherwise, power is consumed at all the other times. And we also find that even when both the current and the voltage both are negative, power is positive, because negative into negative will be equal to positive. So power is positive even in this cycle, even in this half cycle when both voltage and current are having negative values. So this is the graphical representation of power in purely resistive circuit. From this graph we find that in pure resistive circuit, power is consumed at all times, only except at the instant when both V and I are 0. And even when both voltage and current are negative in this interval, power is positive, because voltage and current both are negative, and if we multiply negative with, and power is the product of small v and small I, so if we multiply negative into negative, it comes out to be positive. So during this interval also power is positive. Now let us draw the phasor representation of the alternating voltage and the alternating current. For this we consider a length of the line which is equal to the maximum value of the current amplitude, and similarly the voltage amplitude is more than the current amplitude. So we have drawn a larger value of Vm, and since both Vm and Im are in phase with each other, so they have been plotted along the same line, and the angle which Vm is making with the reference axis is omega t, which has been shown in this figure. Now if we obtain the projection of this Vm on the y-axis, then this value will give the instantaneous value of the alternating voltage. Similarly, if we draw the projection of this Im on the y-axis, then it will give the value of the instantaneous value of the alternating current. So this is the phasor representation of the voltage and the alternating voltage and the alternating current in case of purely resistive circuit. And this is the graphical representation of both the alternating voltage and the alternating current in case of purely resistive circuit. And this is the graphical representation of the power in case of purely resistive circuit. So from this discussion we find that in case of purely resistive circuit, there is no phase difference between the alternating EMF and the alternating current. That is, the phase difference between both of them is 0.